Hello, ladies and gentlemen. Welcome once again to our virtual classroom. Let's get started with our lesson today, which is actually both what we did on Monday and what we continue today on Tuesday. But I do want to cover pretty much everything that we're looking at, um, especially because today's lesson is something that is a bit odd. It's not as straightforward as a lot of things we've done in math. But let's begin by copying down the heading. So if you haven't copied it down yet, or if you missed something, please feel free to pause the video and continue. We're doing SB 11-2, Evaluating Expressions, being our 24th lesson, and we're doing numbers 3 through 11 and number 16. So in math, when we're talking about expressions, that's a term that you'll see very often, expressions. And it's simply, you can think of it as a problem. For example, like, let's consider an equation, like 3 times 7. All right. 3 times 7 would be an example of an equation. 3 times 7 is equal to 21. This would be an equation because we're using an equal sign. So this as a whole is considered an equation. However, if we consider what we have over here on this side, 3 times 7 by itself, this is considered an expression. So you can think of an expression as the problem part of the equation, only the problem, the things that you're adding, multiplying, or dividing, or subtracting together without the equal sign. There's no answer given, or there's no definite answer for that problem. So for our purposes, equations have equal signs, expressions do not have equal signs, okay? And evaluating simply means work it out. So we're going to be working out expressions. We're going to be working out math problems, basically. And however, not only do I want you to think of this as working out math problems, but really we're going to be using math to tell stories, or rather to describe scenarios today. And so that makes it a little bit odd for a lot of us because we're not used to using math in that way, even though we do that. A lot of us do that every day. Anytime you've been to the store, anytime you're planning a trip, um, really anytime you are, I don't know, you go to an amusement park, you go to a restaurant, you are in essence using math in a specific scenario. And so our scenario today, our story today is that you and I are going to be going over to a fair. Okay, so as a class, I guess we're going to a fair. And at this particular fair, and this is all, I got this table from number 1 in our textbook. So if you're wondering where I'm getting all of this information from, I did get it from number 1 here in our textbook. All right, so at this fair, we are going to be paying $3 for each ride. Okay, so $3 for each ride. So obviously, if you go on one ride, that's going to be $3. If you go on 2 rides, that's going to be $6. If you go on 3 rides, that's going to be 9, etc. And we're going to continue this pattern. And as you can see, the pattern described is we're going by threes, or rather we can take the number of rides, which I'm just going to abbreviate that with an R, the number of rides, and we're going to multiply that number, whether it be 1 ride, 2 ride, 3 ride, we're going to multiply that by 3, and that's going to give us the total cost. That's going to give us the total cost of that ride. For example, if you went on 4 rides, so that would be 4 times 3, 4 times 3 is going to give you 12. So that instead of having to write this massive table, you can just be like, well, the number of rides, that's R, and you multiply it by 3, and that's going to give you your total cost, right? This is the expression, though, that we're interested in. All right, if you're going to tell, if somebody asks you, how do I know how much money I need to bring for the rides? You would tell them, well, it depends on the number of rides that you go on. That's the R, the number of rides. And you multiply that by 3. Notice how we see that in number 3 here. Number 3 is, well, what's the cost for 6 rides? Well, I would take the number of rides and I would multiply that by 3. So that's going to be 6 times 3. And 6 times 3 is going to be 18. That's going to be the answer to number 3 because that's going to be the cost for 6 rides. And notice how that is exactly what I see up here in the table as well. Let's continue. Number 4, a numeric expression, there's that word, a numeric expression for 8 rides. Now notice that it's not asking for the cost of it, right? It's asking for the problem part, for the expression part. So that's going to be 8 rides, that's the number of rides, times 3. There you go. That would be the numeric expression. I know that would cost $24 because 8 times 3 is 24. If you continue this table, you see that that'd be 24. However, we just want the numeric expression part. Number 5, very similar. What's the numeric expression for 12 rides? Well, that's going to be 8 times. No. I am so sorry. I'm sorry. That's going to be the number of rides, which is 12. And again, times 3. Now, if you notice in each one of these problems, it's always times 3. It's always times 3 because no matter the ride, it's always going to be $3. That's the cost for everybody. However, if we all were, if a class, if you and I were to go to the fair, are we going to ride on the same number of rides? Not necessarily. Unless we were all going on the same exact rides, which is probably not going to be the case. Chances are one of my students is going to go for a lot more rides than what I am. They might go on 6, whereas I might only go on 2. So that number of rides is going to vary. That's why if somebody asks me, well, how much money should I bring? I would tell them, well, it depends on how many rides you're going to go on. Just make sure that you have $3 for each one of those rides. And so anytime you encounter a problem where something is varying depending on what the person chooses, where the answer is going to be different from person to person or potentially different from person to person, like how many rides are you going to go on at the store, or how many pets do people have, etc. We are going to use not a number, but we're going to use a letter known as a variable. And that letter or a variable is going to be a letter or symbol that represents an unknown number. A letter or symbol that represents an unknown number. And I encourage you to write that definition down on your notebook. So a variable is a letter or symbol that represents an unknown number. So again, in our example, we said that no matter what, you are going to have to pay $3. You're going to have to pay $3 for each ride, correct? However, I don't know how many rides you're going to go on. I don't know. That could be 2, it could be 4. That's going to vary from person to person. So therefore, I'm going to use a letter to represent that unknown number. So I don't know how many rides you're going to go on, so I'm going to use the letter R. So the number of rides times 3. In math, however, when you're multiplying a variable times a number, you always put the number first. So it'd be 3 times R. So $3 times however many rides you go on. And in math, whenever you're multiplying a variable times a number, you actually don't need the multiplication symbol. You just write it together like that. 3R. That means 3 times R. This would be the mathematical appropriate way of writing this 3R. That means 3 times R. So this is our expression for finding out how much money you need for the rides at the fair. It's 3 times the number of rides. Rides times 3. Notice how we have a variable here. In here, the letter R would be the variable. Okay, in any problem, if you have something like 27 times P, P in this case would represent an unknown number that could change depending on situation. So P would be the variable. The number next to the variable, the number that we're multiplying the variable by, that is known as the coefficient. The coefficient. So in this case, in 3R, 3 would be known as the coefficient. R would be the variable. Moving on to number 6, it says, well, write out the expression for everything that we've done so far. So that expression would be, again, because we're multiplying R times 3, would be 3R. 3 times R. 3R. That would be the expression. So on Schoology, you would literally type in 3R. No space, nothing like that. All right. And again, in number 7, it's just asking which of these is the coefficient. The coefficient is 3. And it's asking which is the variable. The variable is the R. That's just something for you to know. I don't even think Schoology really asks for that. All right. So let's go ahead and go to number 8. So let's scroll down to number 8. And number 8 simply reads, evaluate the expression. So our expression is 3r. All right, it's 3 times the number of rides. When r is 12. In other words, r is 12 means that we are going on 12 rides. So instead of writing 3r, I'm going to write 3 times 12. Remember that when you have a number separated by parentheses, that means multiplication. So 3 times 12. So whenever we're going on 12 rides, the answer would be 36. We would need $36. That would be my answer. So again, don't let this be confusing. Instead of writing a whole massive table and putting, well, one ride is $3, two rides is $6, three rides is $9, and going all the way to 12, I can just say, well, just multiply the number of rides that you're going to go on times the $3 that you need for each one of those rides. And if you're going to go on 12 rides, so R represents the number of rides, then you can do 12 times 3, and that is 36. That's why I got that. All right. So when going to the fair, and let me erase this so that we can go over it again together. So let's go to number 9. So when going to the fair, ladies and gentlemen, not only do I need to take into account the money that I need for rides, which is $3 for each one, but when going to the fair, there's also a cost to go in through the door. You can't just go and hang out with your friends there. You actually need to pay money to go inside, to buy a ticket to go inside. And that, in this scenario, is going to be $8. Now, that is known as general admission, or the cost for getting in. You can call it the entrance fee, general admission fee, cost of admission, whatever. Now, the thing about that is that even if you went on 0 rides, you still need to pay those $8. So you can't just bring enough money for the rides. You also need money for the admission cost. All right. So that means that our expression is going to change just a little bit. It's going to change just a little bit because it's not just going to be 3R, which is what we need for the rides, but we also need to include or add, there's addition, the entrance fee or the general admission. So a more complete expression for how much money we're going to need to go to the fair is going to be 3R plus 8, or 8 plus 3R, which is the cost, the expression that we have for the cost of the rides, plus the $8 that we're going to need in the first place. So really, if we're going to go on 6 rides, then we would do 3 times 6, because that's the number of rides, but we also have to include, the $8 for the admission. So if I work that out here on the side, so we have 3 times 6 plus 8. So obviously, order of operations, we do parentheses, exponents, division, and multiplication, and here's the multiplication. 3 times 6 is 18 plus 8, and obviously now we just have to do the addition. 8 plus 18, that would be $26. So think of it this way. If you went if you were going to go to the fair with a whole bunch of your friends, and you guys all said to each other, hey guys, make sure you bring enough money. We're going to go on 6 rides. And you were like, oh, well, if each ride is $3, then I just have to bring, so 3 times 6, that's going to be 18. So all I need is $18, right? You're going to show up and your friends are going to be like, why did you only bring $18? And you're going to be like, well, we're only going on 6 rides, right? Well, 3 times 6 is 18. They're like, dude, you need money to get into the fair first. And you're going to be like, oh, that's right. And so guys, you need to make sure you bring those $8 too. So really, even though you only need $18 for the rides, you really need $26 because you need to get in the first place. So that's why we're doing 26. Sorry, that's from down here. $26 to get in. That would be 9B. So 9A would be the expression. 9B would be working out the expression where the rides are 6, and that would be 26. Hopefully that makes sense. Okay, let's move on to number 10. So not only are we going to have an entrance fee, so here Ayana is our character, but we're just going to put ourselves in her shoes. So not only do we need to go to the fair, not only are we going to need to buy ride tickets, basically, we're not just going to get on rides, but there are also games at this fair that we are going to take advantage of. However, for the games, it's not going to be $3 for each game as it is $3 for each ride, but for the games, it's actually only $2 for each game. So if our expression for the rides was $3 times each ride, our expression for the games is going to be $2 for each game. So let's update our expression. So again, firstly, you need $8 to get in, right? Then you need $3 for each ride that you're going to ride, and you need $2 for each game that you're going to play. And that is 10a. That is our new expression. 8 plus 3r plus 2g. 8 to get in, $3 for every ride, which again is going to be different from person to person. That's why I'm using a variable in this case r, and $2 for each game. And again, I don't know how many games you're going to play. It's probably going to be more than me, but because that's going to differ from different person, it's going to vary from person to person. I'm going to use a variable, a different variable, in this case g. Okay. So as you notice, we're adding more and more situations to this problem. And ladies and gentlemen, each of those situations is different. In fact, each of these can be seen as a term. All right, we have 3 different terms, 3 different situations, each one a different part of the scenario. So those are actually known as terms. So in our notebooks, I want you to go ahead and copy down this definition. Feel free to pause the video as you do. And that is term. A term is a part of an expression containing a number, a variable, or both. So and terms are separated by either addition or subtraction signs. Addition or subtraction signs. So in our scenario, we had 8 plus the rides, which is 3 times each ride, plus the games, which is going to be 2 times each game. So if you notice here, we have 3 different situations. Notice how it's an expression containing a number, a variable, both. So here we have a number. All right, so that would be an example of one term. And they are separated by addition or subtraction sign. So here's my addition sign. So there, that separates these 2 terms. Here's a number and a variable. And here's another number and a variable. And again, they are separated by an addition sign. So that would be 1, 2, 3 terms. Here's another example of an expression that has 3 terms. 3x plus 7y minus 10. Notice how they are separated by addition and subtraction signs. Here's 1, 2, 3 different terms. 3 different terms. It almost looks like a train where each of the carts is separated by an addition or subtraction sign. And again, each of these terms in an expression represents a different aspect of the scenario, a different aspect of the story. All right. So again, in number 10, whenever I had the admissions, which was 8, that's one term. I had the rides, which was 3r, that's another term. And I had the games, which was another term, that would be 2 times each of the games. All right, so let's go back to number 10 and let's do 10b now that we have our expression, which again is 8 plus 3r plus 2g. So let's evaluate this expression and find the total cost if we go on 4 rides. Let me do that in blue. If we go on 4 rides and we play 3 games. Okay, so firstly, we're going to have to get in. So that's going to be $8 no matter what. And then we're going to get on 4 rides. So that's going to be $3 for each one of those rides. So instead of an R, I'm going to put a 4 plus $2 times each one of those games. Oh, and we know how many games that is. It's going to be 3 games. So 2 times 3. All right, let's go ahead and work this out. I'm going to work it off here on the side. So you have 8 plus 3 times 4. So we have addition, multiplication, and multiplication. So let's begin with multiplication. So 8 plus 3 times 4 is 12, plus 2 times 3 is, well, 2 times 3. Let me do one step at a time. Now I have addition, addition, and multiplication. So I'm going to do multiplication first. So that's going to be 2 times 3 is 6. So it's going to be, I'm going to bring everything else down. So I have 8 plus 12 plus 6. So 8 plus 12 is 20. 20 plus 6, and 20 plus 6 is going to be 26. So if I want to go to the fair and get on 4 rides and play 3 games, I need at least $26. I need $26 exactly, actually. That just happens to be the same answer that we got for 9B, but instead of going on 6 rides and no games, now I'm going on 4 rides and playing 3 games, and it's $26. Okay. So number 11, what are the terms in that expression? Well, the terms are 8, 3R, and G and 2G. Those are the 3 different terms that I found for 10A. Those were the 3 different terms. All right. And that's pretty much it as far as our scenario with the fair and the carnival. Hopefully it was it made some sense. I know it's a little bit different. It's a little bit new, but it's not too difficult once you begin to understand that variables in math are things that we use whenever a number can mean different things. For example, let's go ahead and go down to number 16, which is one of our problems here. And let me restart this. Obviously, I was working on this already. So I'm only going to do a few of these. But notice how number 16A reads. So I'm going to, in your notebook, I would want you to write 16A and then rewrite it. We have 8A, okay? And there, but then it says when A is equal to 2. What does that mean? It says to evaluate each expression for the given value of the variable. Okay, so in other words, here we have an expression 8A, and again, when we have a number next to a letter and there's nothing separating them, that means multiplication, right? So we're multiplying 8 times whatever A is. And they're telling us instead of an A, you use a number 2. In other words, A is equal to 2. Okay, so I'm going to rewrite it, but instead of writing an A, I'm going to write a times 2 because it's multiplication. So 8 times 2 is 16. So that would be the answer. Let's try another one. Let's go ahead and do 16B. 16B, we have x over 7. All right, and that is when x is equal to 21. In other words, let's consider x over 7. Remember that anytime we have a fraction, it always means division. So this is really the same thing as x divided by 7. But instead of an x, I'm going to use a 21. So I'm going to do 21 divided by 7. And I'm just putting it in parentheses again, just to focus on the fact that I am substituting it, that I'm putting on a 21 instead of an x, and I'm putting it right there. So 21 divided by 7, and obviously that's equal to 3. Let's do one that's a little bit harder than that. Let's do C. In C, we have C to the 3rd power minus 1. However, instead of a C, we're going to use a number 4. That's really what that means. Instead of a C, we're going to use a number 4. So let's go ahead and rewrite it, but this time let's put a 4 instead of a C, and 4 to the 3rd power minus 1. Now, remember that exponents, that means that we have 3 number 4s right here. There's no 3 here. It literally means, so 4 to the 3rd power literally means 4 times 4 times 4. This is the number of 4s that we have. So there's 3 4s and we're multiplying them together. So 4 times 4 is 16 times 4 is 64. So this means 64 minus 1, and 64 minus 1 is 63. That's pretty much how we do these, ladies and gentlemen. Obviously, you still have to do D and E if you haven't done those. But hopefully, as I went through this, it made sense that whenever I have a variable, that number can mean different things, but they're telling you in this case what they want that variable to be. All right. So, ladies and gentlemen, I hope you found this helpful. hopefully not too confusing. We're going to keep working on similar problems for the rest of the week. All right. I will see you again soon.